What is G-force? Gravitational force. That's it.
Breath. You're on top. Breathe. 1, 2, breathe. Drop the shoulders. Breathe. 1, 2, breathe. Squeeze your legs. Squeeze your butt. Hey, squeeze. Keep squeezing. Keep squeezing. Keep squeezing. Are you there? How you doing? How you doing?
No, alright.
You know what happened?
No, I don't.
Or when you get on the gondola or roller coaster in the amusement park, you feel nauseous, your blood is drained, your eyes feel like they're going to pop out of their sockets. This is G-force. But these examples are actually very low forces compared to the ones I will talk about shortly. There are forces in the universe that can cause a person's bones to break or a skyscraper to collapse like a piece of paper. We will look at all of them with examples, but let's take a brief look at what G-force is and how it is calculated. The 1 G-force is the most fundamental G-force. In other words, this is the force that keeps us and everything in the world on Earth. This is the standard value. In other words, in normal cases, we do not feel the G-force, but as in the examples we mentioned, or when you get into a sports car, you feel it. For example, F1 vehicles sometimes reach 5 G-force momentarily during hard cornering. You can think of this as 5 times the standard G-force. Or if you weigh 70 kilos, imagine that at 5G, your body feels like 70 pi 5, 350 kilos. Or conversely, at 0 G-force, you do not feel your weight. For example, astronauts are in this situation when they are in space. Astronauts who live with almost 0 G-force for a long time have difficulty even standing when they return to Earth because their muscle mass is weakened. And even the legend of man growing taller in space is based here. This is not actually a myth. Without the force exerted by gravity on your spinal cord, the discs will open up a few millimeters apart and you may actually become a bit taller. But unfortunately, this is not permanent, and when you return to the world, you return to where you started as the discs begin to put pressure on each other. As for how it is calculated, for example, let's calculate the acceleration of a Bugatti Veyron and how much G-force you will feel when you are in it. If you divide the maximum speed by the time required to reach this speed and divide the result by 9.81, you will find the G-force you feel. By the way, 9.81 m/s2 is the gravitational constant and was found by Newton. The meaning is this: if you drop an object from a height, whether it is an elephant or a feather, air resistance, friction, etc., if you remove all factors, such as from the equation, this object will fall towards the Earth's core, accelerating at 9.81 meters per second, with the effect of gravity alone. In other words, both the elephant and the feather will hit the Earth at the same time. Therefore, let's say the maximum speed / time, 9.81, that is 100 kilometers per h in the case of Bugatti, which is 28 meters per second, and those who know that it reaches 100 kilometers per h in 2.3 seconds. In this case, 28 halves. 3 equal sign 12 m per s and 12 ninths. 8 equal sign 1.2 g. So this force, where you feel like your brain is sticking to your skull, is only 0.2 g more than the standard G-force. Is it less? Not. But when you look at the examples we will talk about shortly, you will understand what I mean. For example, while the Bugatti feels 1.2 G-force while accelerating, astronauts in a space shuttle are exposed to 3 G-force during takeoff. It can be more concrete if you think of the G-force in all examples as your body weight x the G-force in question. So in this example, the astronauts feel their body weight is 3 times greater. But the pilots of specially made vehicles competing in the drag race called Top Fuel feel it more severely. These pilots can experience a G-force of over 4.2. You don't need to participate in these races to experience this level. You can also experience a more intense G-force by riding a roller coaster. On the most advanced roller coasters, your body is exposed to a force of 6G, especially during sudden turns. So if you weigh 70 kilos, you may feel like you weigh 420 kilos for a moment. When you are exposed to this force for a long time, injuries and fainting will occur. But the gurus of this business in the world are jet pilots. Pilots are exposed to forces of up to 12 G during sudden turns, dives, or takeoffs. For this reason, they are exposed to very difficult training and tests that very few people can achieve. In some of these trainings, they are momentarily exposed to serious G-forces in machines called centrifuges. Sometimes they experience a condition called G-lock. G-lock can be explained as the blood in the brain being pulled down due to the G-force and being momentarily deprived of oxygen. In this case, the following happens.
Are you there? How you doing? How you doing?
Doing alright.
You know what happened?
No, I don't.
Huh?
No.
G-lock.
An American fighter pilot named Eli Beading was exposed to the highest G-force known to have been experienced by a human. During the Cold War, some tests that were considered too dangerous to be carried out on a manned aircraft were carried out with equipment called rocket sled. In 1958, Eli Beading volunteers to participate in one of these tests. And at the end of the test, the vehicle is exposed to a force of 82.6 G for 0.04 seconds while slowing down. This is a force that could directly kill a person. But since it was for a very short time, he managed to survive. But even in such a short time, it caused many of his veins to burst. This was a controlled test and was the highest G-force ever experienced by a human in a controlled environment. But much higher forces are experienced by thousands of people every day. Of course, not on purpose. A vehicle is stationary at a high speed. When T hits a wall, tree, or other vehicle, much higher forces are involved. In fact, an example of this was experienced by Indy racing driver Kenny Brack, who experienced almost 3 times the G-force experienced by Eli Beading as a result of an accident. During the race, as the vehicle moves at full speed, the brakes of the vehicle lock, and at this moment, Kenny experiences a force of 214 G. He feels that his body is 214 times heavier, about 15 tons. Of course, almost all of the pilot's bones are broken, and some of the bones in his ankles are collected by runway officials from the runway, and these bones are reattached to the pilot through the operation. Let's increase the level a little more. Did you know that all these examples and many more G-forces occur in your home every day? In your washing machine. During drying, your washing machine, which is literally a centrifugal machine, produces a force of 400 G to dry your socks. Now, if we turn our eyes a little further away from the world, the power of the universe appears before us. Take neutron stars. Neutron stars are formed as a result of the collapse of the remaining materials of supernova explosions under the influence of gravity. Although their masses are very large, their volumes are incredibly small. For example, there are around 2,000 neutron stars in the Milky Way galaxy, and the mass of the neutron star closest to us is twice that of the Sun. But when we look at its volume, it is only 10 kilometers in diameter. As a result, its density and therefore its gravitational power is incredible. For this reason, the gravitational force, that is, the G-force, of a neutron star is at the level of 7 trillion G. This means, if you somehow placed a skyscraper made entirely of steel on top of a neutron star, it would take seconds to flatten. And this skyscraper is subjected to such a serious force that you can eventually put what remains of the skyscraper in your pocket and leave. Finally, let's talk about the highest G-force thought to exist in the universe. From Planck acceleration. The concept of Planck time was developed by Max Planck and refers to the shortest measurable time period. He formulated it as follows. Remember that the G-force is calculated by dividing the speed of an object by the time it takes to reach that speed, and that the highest speed that can be reached in the universe is the speed of light. The theory called Planck acceleration talks about an object reaching the speed of light in Planck time. And the resulting G-force in this case is, I don't think it goes without saying that this is a huge number. And this force is thought to have been reached once in the history of the universe. About 14 billion years ago, during the Big Bang. It is believed that there are similar forces within black holes. But of course, this is one of the subjects on which science has very little knowledge yet. One step further than this falls within the scope of quantum physics. Let's look at it together another time. Thank you for your time. See you soon.